This video is going to discuss about the Routh stability criterion. As you know, the control system in various methods to find out the stability criterion. Here in this Routh stability criterion, this it is based on arranging the coefficients of characteristic equation into an array called Routh array. First, we have taken the polynomial equation or the characteristic equations. Here, the equations is q of s equal to a naught s power n plus a1 s power n minus 1 plus a2 s power n minus 2 plus etc. plus an minus 1 s power 1 plus an equal to 0. So this is one of the polynomial equation or characteristic equation. We know that characteristic equation is taken from the transfer function denominator term is equal to 0. In the first step, we have to take the two columns, that is for the formation of a Routh array we have to take two columns, that is the first column here, this is s power n minus 1, s power n minus 2 and so on, and this column is the coefficients, that is s coefficients. Here the a naught is the first s power n coefficients, and here the a1 is the second term coefficients. So like that, what is the first maximum power? So bring out and put here a naught, and second one, this is the even number, that is even number power, and we next term we have to write the next even number, that is a naught is the first coefficient and a2 is the second even number coefficient, that is put here a2 and so on, a4, a6 and so on. And second row which was taken from the a1, that is the odd number power, maximum odd number power of this equation, that is a1, and second odd number power, that is a3, and third one a5 and so on. So first we have to write the two rows from these equations, that is a0, a2, a4, a6 and so on, and a1, a3, a5 and so on. And next b1, b2, b3 and c1, c2, c3 we have to take by using a formulas. First b1 term is need to write, that is the formula which is used a1 a2 minus a0 a3 divided by a1. Here first we need to bottom a0 to a2, and we have to take a1 and a2 minus a0 and a3 from top to bottom, a0 into a3. So we have to write and put here the denominator element is a1, this is the first element, and similarly b2 we have to write a1 a4, that is we have we hide this term, that is a1 and a4, and minus a0 into a5, a0 into a5, this term divided by same first element a1, and b3 also same, this a1 into a6, and if it is not putting the any term, you assume as a 0 here. Okay, like that the formula has to be used, b1, b2, b3 and so on. Similarly, and c1 now we are looking about the bottom column and the above column. So as we know that c1 formula we have to take from bottom to top, that is b1 to a3 minus a1 into b2 divided by this first element b1. Similarly c2 we have to take b1 into a5 and minus a1 into b3 divided by b1, and c3 and also same ac1 that is b1 into 0 minus a1 into here same as 0 divided by b1. So it will be a 0. So like that all the element have to use this formula and putting whatever the term, okay, d1 d2 and e1 e2 whatever may be, till that a single element will be till that S naught. Okay. Now the statement is to be followed here. For a system to be stable, it is necessary and sufficient that each turn of first column of Routh array must be positive. Okay, and if A naught is greater than 0, which means we have to look at the first column. So this is the first column of the Routh array. If it is change occurs in sign, given the system is unstable. If it is not changes the sign, means the given system is stable. For example, if the element here we having minus C1, means here the positive sign to negative changes occurs and negative signs to another will be a positive. So there are two sign changes occurs. So the poles which moves from left of plane to right of plane, so the given system will be unstable. This is the statement of the Routh stability criterion. Okay, once again I follow this statement. For a system to be stable, if it is necessary and sufficient that each turn of the first column of Routh array must be positive, and if this condition is not made, the system said to be unstable, and the number of sign changes in the first column corresponds to the number of roots of characteristic equation in the right of S plane. Okay, so this is the first column. It should be observed is very careful. This is the first column only decides that the given system is whether it is stable or unstable. Okay, thank you. The problem will be discussed in the next video.